Cosines review. Okay, I just said law of cosines is helpful, and you guys said side, 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 and I said yes, but which formulas would you use for side, 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 the left or the right? Why? Because you can plug in the side, side, sides, and you need to find the angle, and it's ready to go as soon as you do what to both sides? Cosine inverse to both sides will get you the angle. So technically, couldn't this be A equals cosine inverse of, and B equals cosine inverse of? Yeah. So what's the other case where these formulas are helpful? Side, angle, side. Careful. Side, angle, side. Side, side, angle. Ooh, angle, side, side, bad word. Oh, yeah, that's the tricky one, law of sines. But side, angle, side, side, angle, side. You have two sides in the included angle. The letters aren't going to match, but you're going to be able to solve for the other side. However, as we've been doing in 6.1 and 6.2, if you have to solve for the whole triangle, you're not going to be able to just use this once. You're going to have to either use law of cosines twice, or maybe use some stuff from geometry, like 3 angles add up to 180, or maybe use some stuff from law of sines. Kiddos, we weren't able to finish this example yesterday, so just turn back a little bit before Heron's formula. The last example we were doing, maybe you finished it, maybe you didn't, but we did an example where we said, hey, we have a side, angle, side. B and C. We can plug into our equation as long as we have angle B, which should be the B squared equals version. But the one thing we didn't get to do because we ran out of time was solving for B by square rooting. And so some of you guys might have already actually gotten it because some of you were ahead of me on this one. I'm just throwing it in real fast. 2 times 6.2 times 9.5. Nice thing is your calculator totally gets parentheses. You can even write it in the same way that I have it written here. I know this is silly, but how could you do 20 minutes? There are 2 different ways. 20 over 60, you could just write the little conversion like the little bridge, or second apps, good, and do the minutes symbol in degree mode. I got 10.667. Anybody matching up with that? If not, just tell me no. Uh-oh. Double checking. Square root of 6.2 squared plus 9.5 squared minus, oh, I didn't put 2 times. 2 times 6.2 times 9.5 times cosine of 75 in 20 minutes. Ah, 9.943? Oh, stink. Ah, Aiden. Whew. Aiden and I got it. Anybody else? Double check us. We could have both made the same mistake. It happens sometimes. Has anybody noticed in homework it's really easy to make a little baby mistake and then mess it up? That's why you have to check those odds, right? Make sure you're doing it correctly first. Where'd you get, Tony? 98. Just my head makes that weird because of the 6.2 and the 9.5. That'd be a really weird triangle. Doesn't mean it's wrong. You guys know me by now to say that I do not claim to be perfect in any way, shape, or form. Experienced, but not perfect. Kyle's matching up. The rest of you guys, let's make sure we can use our calculators. I think we're good since we have 2 people matching up with me. But keep on working with your calculator. Reach out to someone. Oh, a few more. But we're not done yet. Are we? Don't we still have to find another angle to find the third angle? Does anybody have a plan of attack? Oh, you didn't square root it, Tony. Thank you, thank you, thank you. So you put it in perfectly. You just forgot the square root. Thanks, Gavin, for seeing that. Who do you guys want to go shooting for? Angle A or angle C? Sure. Angle C. Anybody going for C is equal to cosine inverse of? Do you guys know? I'm using the cosine of C variation. I'm taking cosine inverse of both sides. And maybe some of you are already trying to memorize. Good idea. Maybe some of you guys are already trying to memorize the law of cosines. Whenever we have angle C, my bad. Whenever we have angle C, we're going to be using A and B. Why am I doing a dot, dot, dot for B? I want to use the whole thing, not just one, because I don't want to introduce error. Since we have these nifty calculators, we can scroll up, get the whole decimal, and not just use the rounded version. And I don't think, yeah, it's 9.943018. I'm going to go stealing that. I'm not going to use the cutoff one. I'm going to use the longer one. Isn't it minus? It's a squared plus b squared minus c squared? All over 2 times, not that guy. So 2a, which would be 6.2, and b, which is 9.943, dot, dot, dot. So we could find angle C by using law of cosines, but another variation. Once again, I like using that nifty-difty little fraction feature. How do you guys get the nifty-difty fraction in your calculator with a top and a bottom? Alpha y equals enter. If you don't know how to do that, reach out to someone in your group that has a calculator and be like, guys, let's figure it out. I want everyone in their group on one calculator to have that fraction-y. Get that nice little fraction-y thing. Get that little fraction-y thing. Top, bottom. Just prove to me that you can do it. You guys know what I'm talking about? Okay, make sure you know how to get there. Makes everything easier. Yeah, it doesn't. So, with yours, what you're going to have to do, just because it's like an old operating system and you can't get this operating system on there, it's like an iPhone that won't talk to an older iPhone, you're going to have to go ahead and use big old parentheses. So the numerator is going to have to be in big old parentheses. Actually, in yours you should be able to do second enter, and you can go, that's going to be annoying. You can do your cosine inverse. You can do your second entry. Did you get it? The 9.943? Okay. So you can do your cosine inverse of, actually it might be harder, because if you do second entry, you're going to have to go like deleting stuff. It's probably going to be easier to go ahead and plug in. So it's going to be 6 point, numerator, 6.2 squared plus, you can do second answer though, which is second negative. That will be that number. So that's kind of nice. You don't have to type the whole thing. That's minus 9.5 squared. And then check it. The numerator's done. Just do one parenthesis. So that's your whole numerator. Yeah. But sadly, I know, I wish I could get you that nicer one. Yeah. Oh. Yeah. Okay, sorry guys. I was showing and making sure everybody knew how to use their calculators. Almost all of yours can do the nifty-difty fraction-y thing. We should be comparing, or we should be, I should say, matching up on our answers. What'd you guys get? 4.7, so then round it up to 5.6. 5. Yeah. And the reason why we can stop there, Gavin, is because, yeah. Well, there is an angle left, but technically with the angle, right. So I'm going to do the 180 minus what you guys had, which was 67.56. Give me a few more decimals since I didn't do it, Gavin. Sorry. 565. No, 564. 74. That should be good. Minus. And then we have the 75.20. Ooh, 75 plus, which would be minus. Ugh, struggle. Okay. 37.102. Nice. Yeah, question, go ahead. What I technically did, Kathleen, is I just did 180 minus C minus B. But what I actually put in was 180 minus the 67.564 decimals that Gavin told me. And then I put in the minus. Now careful, this is what I had to think about. I'm not sure if you're doing the bridge. If you're doing the bridge, you'd have to subtract the 20/60ths. I almost accidentally added it, which would mess up. Or you could just do the minute symbol. Yeah. But I'm used to doing 75 plus 20 60ths just because I'm too lazy to go to second apps. I mean, it really isn't that hard, I suppose. But the plus would mess everything up because then you would be taking away and then adding. So you would need to put little parentheses if you were doing the plus. But I think if you just write the 75 degrees, 20 minutes, it groups it all together and would subtract it. Double check and make sure that's right. The only other thing I can think of in homework, no, you said everything matched, but the last angle. Okay, that wouldn't make sense. I was thinking SSA, ambiguous case, but then something else shouldn't have matched either. Did that work okay? Okay. Yeah. Okay. To that end, sorry, Heron's formula. Choop, choop, choop. Some of you guys, most of you guys, should know how this thingy works. So, Heron's formula. What do I do? I mean, you have it. What do I do with the example? What are you finding? What is Kyle finding? Because he knows what's going on since he's telling me this. 43 plus 53 plus 72, all divided by 2. What's he finding? The S, which is the semi-perimeter. Perimeter, add it all up, semi, divide by 2, like semicircle. So finding the semi-perimeter would end up getting us a constant, and once we find that constant, what would that be? 90, 160, 168. Is that 84? Once we have the semi-perimeter, we can go straight to the area and say, ha-ha! 84 times 84 minus one side times 84 minus another side times 84 minus the other side. If you want to do that math, go ahead, but you're going to have a lot of big numbers. I have different people plugging it into their calculators. I'm just making sure you guys all remember units, meters squared. But as you plug and chug, as someone's getting an answer, or as a few people are getting an answer, what I'm showing you real quick is reminding you of the work you're saving. If you had a 43, 53, 72, the only way to find this area without these new formulas from 6162 would be finding the altitude. Because we need 1/2 base times height, and how would you find the altitude? Well, stink. We have a hypotenuse, that's well and all well and good, but I need this side also. You'd have to find this angle using law of cosines. Side, side, side. If you found this angle, then you could do sine of theta, that angle equals x over 43. You could solve for x and then do 1/2 base times height. You could do law of cosines and then 1/2 base times height after using trig. You just plug in, but you know the new formula to use it. At least on a test or quiz. What do you guys got for the area? 131.887. You guys agree with 131.887? So many head nods around the room. Go team. Is the formula nice? Yes, if you know it. If you don't know it, there is another way. Could draw a triangle. Could do law of cosines. Could do 1/2 base times height. But I like better. All right, cool kids. Section 6.2. Let's go grade the evens. Boop. 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 Let's go there. 2 and 10 and 34 and almost 36 are all on the screen. But if I were you, I don't know, lots of numbers start to get kind of confusing when they're all in one place. Does the note make sense? You guys notice that there was something chilling up here on the board when you came in that you could recognize? Guess what Calculus AB needed to remember today? Pythagorean properties. Sorry, go back to checking. Number 2. Law of sines, yeah? Number 10, C is equal to 11.06. Angle B is 23.13. Angle A is 51.87. You guys know fractions. They said 2 decimal places. Whatever. I prefer 3. Up to you. Yours should round to theirs, and we should be good. 34 is saying law of cosines. Why? Side, side, side. Angle B, 89.63. Angle A, 57.79. Angle C, 32.58. Kathleen, if you find the weird one, and you can't figure out what's going on with that angle, let me know. Number 36. What? It's a law of cosines homework and you did law of sines? Why? Law of sines is so much easier when you're given at least 2 angles. If you're given 2 angles, law of sines is so much easier. You could. But how? Well, I guess I could find a third angle by 180 minus. But in law of cosines, don't you need 2 sides? So you couldn't actually do law of cosines immediately. You'd have to use law of sines to find a second side, and from a second side, you could go ahead and choose 2 sides and an angle. Ugh. Doesn't that sound gross? I think so too. So long story short, now that you know both, use a given case. Law of cosines is great for side, 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 and side, angle, side. Law of sines is great for angle, angle, side, or side, side, angle, but remember it's the ambiguous case. And we were actually going to, I want to do that. Yeah. Side, side, angle, law of sines, it's sine inverse or 180 minus sine inverse. Law of cosines, 2 sides, you would think it'd be good. But we're going to actually peek at that after we finish homework checking. Using the warm-up from yesterday. You guys got it? 38. Oh, it's Huron's formula. Plug and chug. Lots of stuff. And hopefully you guys got 399.03 something, 04 something. No? Double check your semi-perimeters. 47. 47 minus 33, 47 minus 36, 47 minus 25, and double check you put it in your calculator right. Is it the wrong problem? I was checking something out. Number 55 was a little weird, and it actually describes our side-side angle dilemma with law of cosines. Because I think in 56, double check guys, were you given a side-side angle? For 1 second. Angle, and we were just talking about that one, so hold on, pause. Check 66. Law of cosines, law of sines. Law of sines, but the one right above that we skipped actually shows law of cosines can solve for that too. But we're thinking law of sines is easier, and then SAS, law of cosines. The one that could be a little bit variable, or the one that might be up to interpretation, or up to preference is letter C. Technically, both can do letter C. But SSS is definitely law of cosines. 2 angles, definitely law of sines. Side angle side, definitely law of cosines. So what's going on with the SSA guy? Before I open it up to all questions, let's look at number 56 real fast. As long as it's hopefully here. Please be here. Ah, no. Struggle. Help me out. Was 56 a word problem, guys? All right. We're just going to do this then. Here I was ready for yesterday's questions, but didn't realize today's wasn't going to work. P.S. If you're ever in charge of anything and doing like PDFs, can you guys make sure they work for every page? Be great. Okay. I don't know. Maybe someday. You'll be making textbooks for something. That was exciting. Sorry. 56. Engine design. Oh, but they gave you a picture. It wasn't that bad, right? Like, the picture wasn't bad. What was bad was the given information. Okay, they were giving you like a crankshaft or something? Is that what's going on? Oh, they gave you a rod and then an engine and then... Anyway, long story short. They gave you a side-side angle. 1.5 inches, 7 inches, and then... Did they give you theta? Oh, letter A, though, just said... Right, it's not as exciting. Law of cosines. You don't know your third side, and you don't know your angle. So they went ahead and called the third side x. But law of cosines, don't you guys know that these two have to match up or have to be used together? So we knew it had to be 7 squared equals. Does that make sense? And then you have your other two sides, so 1.5 squared plus x squared minus 2 times 1.5 times x times cosine of theta. That would have been just plugging into law of cosines using x as your missing side. You could have used, I don't know, what would you guys have used, C or BC? That would have been okay. X is just a little bit easier if you have an unknown in like a word problem. That's letter A. Letter B says write x as a function of theta, aka get x by itself. How do we get x by itself, guys? He's kind of stuck in there, right? So what do you guys do, or what should we do, or what's an idea that you have? How do we get x alone? It's hard. But does anybody see a quadratic function? Someone in your calculator, real quick. What's 1.5 squared minus 49? What's 1.5 squared minus 49? I'm subtracting 7 squared from both sides. It combines with the 1.5 squared. What do you get? Now, do you see a quadratic? But that's quadratic. Don't we need an A and a B and a C? Your A is 1. Is your B negative 3? AX squared plus BX plus C? What else is there besides the x? 3 and cosine. Ooh! And then C is negative 46.75. And letter B, part B, it said solve for x by itself. The only way to solve for x by itself is factoring, no. Or, sing the song. X equals negative B. Wait, isn't B negative 3 cosine theta? X equals negative 3. Okay, so positive 3 cosine theta. Negative B plus or minus square root B squared. Wouldn't that be a positive 9 cosine squared? T-proofs, I wonder if that's a thing. X equals negative B plus or minus square root B squared minus 4. A, C, all over who? All over 2A. Ah! That's an expression for x in terms of theta? Wait a minute, I think they said something like keep it positive because it's a real life problem. So that's the sign that yields positive values of x. So is it plus or minus? Hint, plus. So then we would cross off the minus and say, okay, not the minus, just the plus. That's letter B. What's letter C say? Use a graphing utility to graph the function. What? Make that your y and make that your of y. In your graphing calculator, letter C says go ahead and figure out the total distance the piston moves in one cycle. Let's look at our answer key now that maybe it makes a little more sense why they're doing this crazy, oh my goodness, quadratic formula stuff. Now, they technically went ahead and simplified, like they multiplied 4 times 5 and got a number. They actually took this divided by 2 and said, ew, gross, that's going to be nasty to write, so they wrote a 1/2 in front just to make life a little bit easier on themselves. They chose the plus like we chose the plus. Then they went ahead and letter C and they graphed the function. Zoom standard would have been okay because you would have up to 10, you would have gotten this function, and then if you would have gone to 10, 2 pi is 6.28, so you would have seen this. They were asking the highest piston, I think, move. What you could have done is just found the maximum of the graph, and whatever max you found, there are multiple maxes. All the maxes would go up to a height of 8.5. All the maxes go up to a height of 8.5. So they were asking you letter C to graph this guy, and then letter D find the max, and the max was at a y equals 8.5. Whew, that's nasty. But now that we have that question, is SSA possible with law of cosines? Maybe. I want you guys to turn to the back of your homework spiral, the warm-up from yesterday, 6.1. Wasn't it an SSA option or case? The warm-up, the very back of your homework spirals, the openers from yesterday. I'm double checking, but I'm pretty sure I gave you an SSA. Why? Well, there's two cases. That only happens in SSA, right? How did we solve this yesterday, guys? With law of sines. Ready? I want us to do a 6.2 practice. If I were using like a different colored pen in the back of your homework spiral, I would say SSA with law of sines and SSA with law of cosines. SSA is nasty no matter which way you cut it. It's a little tricky. It's not horrible. It's not impossible. But it's a little tricky. So yesterday we did law of sines and we had to do sine inverse and 180 minus sine inverse. Today we're going to try the same exact opener in the back of our homework spirals with law of cosines. Instead. So we're asking ourselves the question, can you do SSA with law of cosines? Let's try it. Wait a minute. Law of cosines is easy if you're given two sides. All you have to do is do cosine of the angle. Wait, no. All you do is matching up the side with the angle, right? We have angle B. No, we don't. We have angle A. I apologize. We have angle A, so we're going to use this form. No big deal, right? But what's weird? I want him to be unknown. Then I can square root both sides and everything is easier. I can plug in this one, but what don't I know? Let's see. How on earth would you solve based on what you just saw? How on earth could we solve for C given this nasty law of cosines? Because what we could do is we could subtract 144. Subtract 12 squared. Get everything equal to 0. We would have C squared minus 62 minus, nope, plus, what's 31 squared minus 144? Or 31 squared minus 12 squared? What's 62 times cosine of 20.5 with a few decimals? 58.0737. Is it possible to solve an SSA with law of cosines? Yes, because it's an ax squared plus bx plus c. And what formula did we just use to solve something very similar? But in this one, everything's plugged in except for the c, so it's not like the other one where you can't really do anything unless you go with or to your calculator. This one, we can actually plug everything in and get c. So c is equal to negative b. Keeping as many decimals as possible. Plus or minus square root. Plus or minus? But I thought it was just plus. Depends. Quadratic formula could give you two positive answers, so then there are two cases. Or it could give you one positive, one negative, which means there's only one answer. Or the discriminant, the underneath square root part, could be negative, which means error, which means 0 cases. We can get 0, 1, or 2 with law of cosines also. So it's up to you as to whether you think sine inverse and 180 minus sine inverse is easier than the quadratic formula or not. B squared minus 4AC all over 2A. The weird thing about using law of cosines for our ambiguous case is that we're actually not solving for angles at all first. Law of sine says solve for angles first. Law of cosine says go solve for the side first. So what do we have? We have 62 cosine of 20.5. Okay. And C is equal to. Remember, for plus or minus, you have to do them separately. You can't do them all at the same time. Squared minus 4AC over 2A. You can do the positive one and you can do the negative one. And the question you're asking yourself, does C has to be a length of a side in a triangle? Are they both positive? Is one of them? Oh, they are both positive. So what does that mean? How many cases? 2. And what did we see yesterday when we did sine inverse and 180 minus sine inverse? 2 options. So one of them would have a C of 34.149. Does that match up with yesterday? And one of them with a C of 23.924. Not angle C, side C. Not angle C, but side C. Looking back really quickly. Oh my goodness, there he is. Ha ha! What would you have to do now? Go find some angles. Go find angle B, go find angle C. How? Well, I guess you could do law of cosines now. You have side, side, side. I'm just going to do a dot, 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 because you have side, side, side. You could do law of cosines, or now that you have side, 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 you could even do law of sines, but I think it'd be a little bit messier. Gavin, go ahead, though. What's up, bud? I plugged into quadratic formula, and when I did it with plus, I got a positive, and when I did it with minus, I got a positive, and positive measurements can be sides of triangles. Yeah. Yeah. So you could do like cosine of, now that we have everything, you could do cosine of C using side, side, side. Cosine of C equals. Good. Because you have to do a cosine of this guy with those two, and then using that guy with those two. And you would end up solving for the unique solutions based on that side. Does that make sense? So law of cosines, you're just going backwards. But either way, once you get one angle, remember, use 180 and all the angles adding up to save time. But the long story short is law of cosines and law of sines can both do SSA, but most of you should think the checking law of sines, sine inverse, to be a lot easier than quadratic. But I was showing you it's possible. You're welcome. Okay, so when we were doing homework, when we were grading homework, and when this one says SSA law of sines, that's probably the easiest, but law of cosines is possible. All right, kiddos, any other questions on homework? Sorry, I didn't ask for anything else because I was proving a point. Not a point that you have to use, but it's a point. Yeah, number 10. Okay, number 10, Robbie, I do have that solution. I'm just grabbing the triangle really quickly so we can look at it. So for number 10, you were given an SAS. With SAS, you'd want to solve for that third side first, which is why they went ahead and plugged in C squared. So once you did C squared equals your formula, you just plug in everybody you know. The A goes in, the B goes in, the A goes in, the B goes in, the cosine of C goes in. Don't forget to square root both sides. That definitely could have been a place that something could have gone wrong, is square rooting both sides. But once you square rooted both sides, now you have side, side, side. So then they went ahead and kept on using law of cosines to find one other angle, using the appropriate formula, plugging in the A they had, the B they had, and then the C that they found. But careful, see how there are lots more decimals than there were to begin with? Keep it with as many decimals as you can along the way. And don't forget to do cosine inverse at both sides. Then just use 180. Is that cool? With that, kiddos, let's introduce section 6.3. No. Okay. Have to get back to 6.3. It's okay. Didn't we see that we're going to take a few days on this? Kiddos, though, what do you see coming? Homework this weekend. Watch Despicable Me. Just kidding. See you guys on Monday. See you guys on Monday. Finish up 6.1, 6.2. Homeworks have been totally ready to go. No fun behind now. Not yet. Save that for later. Bye, guys. Get rest this weekend. You're welcome.